In 2024, the entire planet officially recorded its absolute hottest year in all of human history, marking a stark new reality. This global temperature trendline shows that last year, we crossed the 1.5 degrees Celsius threshold above pre-industrial levels. Yet simultaneously, our thirst for energy surged, pushing global consumption of renewables, oil, gas, coal, and nuclear to all-time record highs. The global economy is currently undergoing a massive parallel energy expansion. Last century, energy security meant guarding physical fossil fuel supply lines and managing geographic scarcity. The International Energy Agency's massive 2025 World Energy Outlook definitively concludes that this traditional definition of energy security is now obsolete. Governments now face a threat matrix, including critical mineral bottlenecks, vulnerable power grids, and unprecedented localized electricity demand. Securing the global economy requires navigating supply chain monopolies and overhauling underfunded infrastructure alongside traditional maritime protection. The infrastructure for the age of electricity is built out of raw earth. This map shows the supply chains for 20 strategic energy minerals. While extraction happens globally, the refining stage is a severe bottleneck. A single country acts as the lead refiner for 19 out of these 20 minerals. Across these minerals, that single country holds an average market share of roughly 70%. This geological concentration is being weaponized. Today, over half of these strategic minerals are subject to export controls. This scarcity contrasts with the massive manufacturing overcapacity for finished technologies, like solar modules and battery cells. The geopolitical oil cartels of the past have been replaced by single-point supply chain monopolies, leaving the modern energy system acutely fragile. For over a decade, China drove more than half of all global oil and gas demand growth. That engine is structurally decoupling. New centers of demand are taking over, led by India and Southeast Asia. Their future energy mix is dictated by geography. This heat map highlights zones with high-quality solar irradiation, which neatly overlap these growing population centers. By 2035, 80% of all global energy consumption growth will occur within these high solar regions. Geography now dictates the physical reality and cost-effectiveness of these power systems, shifting the geopolitical center of gravity toward the equator. As global demand shifts, local power systems are dealing with two massive, simultaneous shocks. First is the expansion of AI. Electricity demand for data centers is expected to triple by 2035, with development highly concentrated in the United States, China, and the European Union. This localized strain in advanced economies contrasts with a distributed load expanding in emerging markets, air conditioning. Rising incomes combined with rising temperatures will add 500 gigawatts to peak global electricity demand in the coming years. These localized loads create severe, targeted stress points on regional power systems that were never designed to handle them. Global energy investment currently prioritizes the creation of power over its delivery. Global investment in generating electricity, like solar, batteries, and small modular reactors, has surged to $1 trillion annually. Annual spending on transmission infrastructure has risen at less than half that pace, at just $400 billion. Pushing that much power through a constrained pipe results in rising curtailment of wind and solar output and an increasing incidence of negative pricing in wholesale markets. The human cost of this fragility is immediate. Weather and operational disruptions to critical power infrastructure recently affected 200 million households worldwide. Generating clean energy provides no economic value if the transmission infrastructure cannot move it. The physical grid determines the speed and security of the entire system. While the grid strains under electrification, the transition is being actively counterbalanced by a massive expansion in natural gas. This map outlines an impending supply shock. 300 billion cubic meters of new liquefied natural gas export capacity starting by 2030. That represents a 50% increase in global supply. This wave will lower prices, incentivizing producers to seek markets in Europe and Asia. Meanwhile, the adoption of electric vehicles will force a plateau in global oil use around 2030, holding at roughly 102 million barrels per day. We are facing an abundance of cheap, clean technology right alongside massive new fossil fuel supplies. In this market, government policy, rather than resource scarcity, will dictate the winners. This chart projects 3 policy scenarios to 2050. The current policies lane sees oil demand climb to 113 million barrels per day, driving high emissions. The stated policies lane forces a plateau. The bottom lane shows the massive infrastructural shift required to achieve net zero. Across all three scenarios, the underlying global demand for energy services is practically identical. The difference lies in the technical efficiency of the system and the fuel mix we choose to power it. The age of electricity offers the potential to decouple economic growth from carbon emissions, but failing to build resilient grids and diversify mineral supply chains will trap the world in a high-friction, high-vulnerability future. Infrastructure is our destiny.